Hello everyone, my name is Francisco García Fernández, and in today's video I am going to introduce to you my prototype of a machine that is capable of detecting defects on MDF boards in collaboration with the industry Aglomerados Cotopaxi Sociedad Anónima. So as an introduction, we can say that in this digital era, we find ourselves witnessing an unprecedented revolution where machines endowed with intelligence are reshaping the very fabric of our industries. And at the forefront of this revolution stands the artificial intelligence, a remarkable technology that has transcended the boundaries of the science fiction to become an integral part of our everyday lives. For this case, we are using the artificial intelligence in order to make a machine compare images in order to detect defects on MDF boards, such as oil damage, glue damage, and sandpaper damage, and also to, of course, detect if the boards are correctly made so they can be moved to a different process in the future. It is important to mention that this machine is not intended just to make an automatic process out of the supply line in the industry. Humans can also manipulate this machine by taking a look at the interface and pressing the buttons that are shown in the manual mode in order to make scan themselves, to move the machine in their desire, and also to take pictures of the boards in progress. Well, first of all, let's take a look at the modes of the machine, which are the manual mode and the automatic mode. We will first take a look at the automatic mode that will go as following. The first usage mode of this interface and this project is the automatic mode. In here, the user can hit the buttons to make a homing procediment or the starting of the analysis. When the starting button is pressed, first the camera makes a homing routine, as you can see right here, and after this it makes a square around 4 of the corners of the board, as you can see right here, so the camera can have 4 shots of the board that is located inside in the prototype. This is later used for the analysis of the project, as you will see right here. Later on, the camera makes another homing routine in order to start from the 00 point if the user desires to analyze another board, and as you can see in the interface, it is displayed the last photo that was taken from the camera. Right now, the conveyor belt is moving to the right, indicating us that the board has some defects. In this case, it has some oil defects, as I am showing you here with my finger. If we go back to the interface, we can see that we have some oil damage in the picture displayed, and also we can see in the shield and in the interface that the oil damage is indicated as well, so the user can know basically what the damage has been found by the artificial intelligence implemented on this project. Now, to check the functionality of the project, I also put a clean board in the prototype, and then I hit the start button once again. So then the machine will start the routine one more time. First it's going to make this homing position, and then after it is going to make the square that was previously made for the previous board. So the Raspberry Pi can have some camera pictures from the clean board in this case. So after this, it returns to the home position, and as you can see, the conveyor belt is moving to the left, indicating us that the board is normal. In this case, as is shown in the interface, the board has been normal all the time, or it presents no damage, and also in the shell we can check the values and that it has detected normal in all the points. And last, I'm going to introduce another board that has been damaged, in this case with sandpaper damage. I proceed to make the routine once more. And after it has finished, it returns to the home position. We can check the picture also in the interface, and we can also see that in machine status it displays sandpaper damage. Since it has found a damage, the board will go to the right from the conveyor belt system, so the board should be pre-processed once again. And right now here I'm going to show you the sandpaper damage in the interface, and in the idle we can check the values, and that the sandpaper damage has been found in the 4 different corners of the board. Now that we have taking an analysis of the automatic mode, let's move on and check the manual mode of the interface, which is quite simple, and this way the users can control the machine at its own desire. The explanation will go as the following. The second modality of using this machine is the manual mode that has been implemented so the user can control the camera system at his own desire, and also to show and capture some pictures with the camera that has been implemented in the prototype. Here, as we can see, I am controlling the camera so it can move first to the left and then upwards, so I can have a clear shot to create a picture of the board that is introduced in the prototype right now. So then after that, I hit the capture button, and in the idle is shown that the capture has been saved, and also I show the photo in the interface. With the interface, we can also make some other movements, for example, the conveyor belt system that bumps the board in the left or right way the user desires, and I can also control the homing option for the camera system to get back to the 0, 0 coordinates in order to initialize a new process in a quicker way. The last thing that we are going to be talking about is the electronic cabinet in which the components are going to be placed. This cabinet is meant to be done for two main reasons. First, for the components to not to interfere with the user, so it can damage the components easily or they are settle down the environment, but also so the user cannot change or add components in a very easily way because of the organization made in the electronic cabinet. So let's go ahead and take a look at the explanation of this part of the project. In order to keep the elements organized, I decided a small cabinet that is used for the storage of the electronic components. Here we can see a CNC shield specifically designed for this project that controls the NEMA 17 stepper motors for the camera mechanism, an NEMA 33 stepper motor driver that controls the conveyor belt system, and an Arduino Mega that receives the signals coming from the Raspberry Pi and gives them to the motors in general. To supply this project, I use a 24-volt 10 ampere power supply and a step-down module that regulates the voltage to 12 volts and 5 amperes for the CNC shield and the Arduino Mega board. As you have foreseen in the whole video, this is my prototype of a machine that can identify failures and damages in MDF boards, and also the machine can detect normal bolts so that it can continue with their normal process. If you have watched this video so far, thank you very much, and I also want to handle my special thanks to the company Aglomerados Cotopaxi Sociedad Anónima to give me the opportunity to work in this very interesting project that is wanted to be applied on an industry line. So that's all for today. Thank you for watching the video. Take care.